This is the Calstock retaining wall project by Grip 2. So firstly, we're going to talk about the site plan. The purpose of the site plan is to show how the proposed structure relates to what already exists in the area, to ensure that local and state building code are followed when alterations are made. The local authority usually will require a site plan. Another important feature for a site plan is to ensure that the local surfaces are equipped for the structure we are constructing. By selecting a scale of 1 to 500, we can easily see every existing road, building and railway in the surrounding area. Additionally, the proposed retaining wall is clearly marked on the site plan to ensure that both locals and construction workers are aware the location of the project. By having a better awareness of a local terrain through the site plan, this can make the following planning of the construction process be made more effectively.
For our cross-section of the failed wall, we try to analysis for reason why is it collapse. The reason one is when it rains, water runs into the soil. If the drain line cannot discharge rainwater in time, the soil with water will exert more force on the retaining wall. It will cause the retaining wall to collapse. And reason two is that there is a waterproof slope below the retaining wall. When the level of the water rises due to raining weather or flood, the water will exert more force on the slope too. The reason three is about the basement. The basement below the retaining wall is the key to the stability of the retaining wall. The filling depth of the basement is not enough, which will affect the bearing capacity of the wall. And reason four is about the type of the soil. The soil below the retaining wall, if it is not stable enough and the types of soil does not meet the standard of building a retaining wall, it will also call a collapse.
For our cross-section of our proposed retaining wall design, we decided to utilize the gabion basket design, as in comparison to other designs it's much more efficient in how quick it is to erect and also the amount of materials used. Furthermore, we don't need to waste time adding weep holes, as the water can seep through the rocks naturally. In our calculations, we considered the sliding and overturning failure, and during our checks, we got a factor of safety for overturning of 2 and a sliding factor of safety of just above 1. The gabion basket design will be filled with interlocking angular stones between 100mm to 200mm wide. This is to ensure the rocks don't escape the basket. We also needed to add a geotextile membrane which prevents the earth from entering the baskets.
So for the first part of our construction sequence, firstly, we're going to analyze the site after collapse and start the removal of debris using an excavator that is going to be brought by a ship from the river. Then there's the insertion of temporary super jaws, which are only one of the only mechanisms which can break through rock soil, and they're going to be used for future excavation on both sides of the broken wall. Then we're going to excavate part of the terrain and remove the first super jaw, which is the same step is going to be repeated for the jaw number 2, and the soil is going to be compacted. Then the sub-base is going to be made by crushed granite, and a geotextile is going to be added for drainage. After that, a steel frame is going to be added, and the cages are going to start being built.
This is part 2 of the construction sequence for our gabion wall. After building the cages, geotextile sheets will be attached to the back of the gabion baskets. This ensures water permeability and a filtration mechanism. The gabion baskets are then filled with interlocking angular rocks such as solid granite or sandstone. After adding the first layer of the wall, the back cavity will be filled with excavated material, specifically crushed granite that was collected from the removed debris. Next, the second layer is added. It is connected to the first layer by a worker using lacing wire. Then the back is filled once again. Afterwards, a third layer is added and a ladder is used for the worker to connect it to the second layer. Once that is done, the back is filled for the last time. Once filled to the brim, the road is resurfaced using a road roller. With this, construction is complete and the final design of the gabion wall has been achieved.
Now for the safety features of retaining walls. The first risk that can arise in the construction of the retaining wall is the fall of construction workers at high walls. So scaffolding is building around the wall to protect the workers. With poor visibility of construction at night, passing pedestrians or workers could easily lose their footing and fall off the wall, and graduates are needed to wear them. Safety helmets are also needed to protect workers' heads during construction.